Have you ever stopped to think about how many everyday objects depend on a single material? From the pipes hidden inside your walls to electrical cables, window frames, medical equipment, flooring, and even credit cards, one material appears almost everywhere: PVC. Most people interact with PVC every day without even realizing it. It has become so common that we often take it for granted. Yet behind this seemingly ordinary plastic lies a fascinating story of chemistry, engineering, industrial innovation, and scientific discovery. PVC is one of the most important materials ever developed, helping shape modern infrastructure, healthcare, transportation, and construction. But what exactly is PVC? How was it discovered? Why is it used in so many applications? And what makes it so valuable compared to other materials? Let's explore the science and engineering behind one of the world's most versatile plastics. What is PVC? PVC stands for polyvinyl chloride, a synthetic plastic polymer made primarily from vinyl chloride monomers. It belongs to the family of thermoplastics, meaning it can be heated, molded into different shapes, cooled to become solid, and reheated again for further processing. At the molecular level, PVC consists of long chains of repeating vinyl chloride molecules. The chemical formula of vinyl chloride is C2H3Cl. When thousands of these molecules join together through a process called polymerization, they create the durable material we know as PVC. One of the reasons PVC became so successful is its unique combination of properties. It is lightweight, durable, resistant to moisture, resistant to many chemicals, electrically insulating, and relatively inexpensive to manufacture. Furthermore, its characteristics can be modified by adding specific additives during production, allowing engineers to create products ranging from rigid water pipes to flexible medical tubing. The accidental discovery of PVC. Like many important inventions throughout history, PVC was discovered by accident. The story begins in 1835 when French chemist Henri Victor Regnault was experimenting with vinyl chloride. During his research, he noticed that a white solid substance had formed inside containers exposed to sunlight. Although he had unintentionally created PVC, he did not fully understand its significance, and the material remained largely unexplored. Several decades later, in 1872, German chemist Eugen Baumann independently observed the same phenomenon. He exposed vinyl chloride to sunlight and produced a white powdery material that was later identified as polyvinyl chloride. Once again, the discovery attracted little commercial interest because nobody knew how to process the material effectively. For years, PVC remained little more than a laboratory curiosity. Scientists recognized its potential but struggled with a major problem. Pure PVC was extremely rigid and difficult to work with. The breakthrough finally arrived in the early 20th century. In 1913, German inventor Friedrich Heinrich August Klett developed one of the first industrial methods for producing PVC and obtained patents related to its manufacture. However, large-scale commercial production remained difficult. Everything changed during the 1920s when American chemist Waldo Seaman, working for the B.F. Goodrich Company, began experimenting with PVC. While searching for synthetic materials that could replace expensive natural rubber, he discovered methods for making PVC flexible through the use of plasticizers. This innovation transformed PVC from a brittle laboratory material into an incredibly versatile engineering plastic. Suddenly, it could be used in thousands of different products, opening the door to widespread industrial adoption. How is PVC manufactured? The production of PVC begins with raw materials derived from two major sources: petroleum and salt. Approximately 43% of PVC comes from petroleum-based ethylene, while the remaining 57% comes from chlorine derived from common salt. This combination makes PVC unique among plastics because it relies less heavily on petroleum than many other polymers. The manufacturing process begins by producing vinyl chloride monomer, VCM. First, ethylene reacts with chlorine to create a compound called ethylene dichloride. This compound is then heated to very high temperatures, typically above 500 degrees Celsius, causing it to break down into vinyl chloride monomer and hydrogen chloride. After purification, the vinyl chloride monomer undergoes polymerization. During this process, thousands of individual molecules join together to form long molecular chains. Several methods are used industrially. Suspension polymerization, emulsion polymerization, bulk polymerization. The result is a fine white PVC resin powder. However, this raw resin is rarely used directly. Instead, manufacturers blend it with various additives to achieve specific properties. These additives may include plasticizers for flexibility, stabilizers for heat resistance, pigments for color, lubricants for easier processing, flame retardants, impact modifiers. The final mixture is then transformed into products using manufacturing techniques such as extrusion, injection molding, blow molding, and calendaring. Rigid PVC versus flexible PVC. One of the most remarkable aspects of PVC is its adaptability. Depending on the additives used, PVC can be either rigid or flexible. Rigid PVC. Rigid PVC, often called UPVC, unplasticized PVC, contains little or no plasticizer. It is strong, durable, and resistant to weathering. Common applications include water pipes, sewer systems, window frames, door profiles, building panels, industrial tanks. Flexible PVC. Flexible PVC contains plasticizers that make it soft and bendable. It is commonly used for medical tubing, electrical cable, insulation, inflatable products, synthetic leather, hoses, flooring materials. This flexibility is one reason PVC can serve such a wide variety of industries. Why is PVC so popular? The popularity of PVC comes from its exceptional balance of performance and affordability. Durability. PVC products can last for decades with minimal maintenance. Many PVC water pipes remain in service for more than 50 years. Corrosion resistance. Unlike metals, PVC does not rust or corrode when exposed to moisture. This makes it ideal for plumbing and outdoor applications.